After 1,668 kilometres of air highway, we finally made it to the other side of the Nullarbor. The Spencer Gulf, the first water we've crossed since Perth. Industry and agriculture are unfamiliar sights. But on this continent, you're never far from desert. Oh look, it's gotten a bit badlands.
Yeah, it looks like we've entered cowboy country. Oh, good thing you got a hat. That's why they call me Mad Dog Muller. I can't believe you just come over those hills with all those wheat fields.
And then this.
It feels prehistoric.
It's a prehistoric mystery that's bringing us to this cowboy country. Paleontologist Rod Wells has spent a lifetime intrigued by Australia's extinct megafauna, massive animals that once roamed this land.
Hello.
Derek, hi.
How you doing?
Very well, thanks. Welcome to the Badlands.
Oh, thank you. This is an amazing landscape here.
It is. It's the classic sort of Badlands landscape. Lots of runaway holes, cliffs, gullies, gulches.
What makes a bad land a bad land?
I think it's the fine-grained nature of the sediments. You know, they very rapidly erode. And it's in these layers, in these banks, that we refine the remains of these giant extinct marsupials.
That's what was discovered here. Back in 2011, on this sheep station 2 hours north of Adelaide, a local came across some very big bones. They turned out to be the remains of the biggest known marsupial, a megafauna called Diprotodon.
So this skeleton you've got for us, it's essentially of a giant wombat-like creature, is that right?
Yes, it is. A giant wombat-like creature would be a good description. This is a huge animal, weighing in about 2 to 3 tonnes.
Wow.
So here it is.
Look at that.
It's the world's largest marsupial.
Jeez.
Here's a familiar bone here, the femur or thigh bone.
That's a massive femur.
Oh yeah, it's huge. And
Is that its head?
And that's the head over there.
Where?
And Aaron's just working around the base of the skull. And here are the front teeth, right down here, the incisor teeth. Down
And
in
so this creature is called Diprotodon, which
there.
means...
Diprotodon, 2 front teeth.
And there they are.
So that skull is 1 metre long.
And you found another one right on top of
There
it.
was another one sitting right on top of this.
Wow.
Pretty good find.
Yeah, excellent find.
The first skeleton has been removed, and now they're working on the second, preserving the fragile bones in plaster casts for transportation. Diprotodon fossils have been found right across Australia, so it's likely they ranged far and wide. But it was these open plains they favoured.
This would be a lovely time of the day to be out here 60,000 years ago because, you know, so many of the marsupials come out to feed just on dusk in the early evening. And I would have expected to see little groups of the big Diprotodons just meandering across the plain there. You know, perhaps a big male and a harem of females and a few young. And they'd be going along and just hooking these shrubs out of the ground with those big incisor teeth and munching them up. Just slowly meandering and chewing them up.
And now they're gone.
They're gone. They're all gone. And in geological terms, not so long ago, 50, 60,000 years ago, maybe 70,000 years ago, we just really don't know. And that's what we're trying to find out here.
Did the megafauna go extinct before or after humans arrived around 50,000 years ago? This is one of the biggest ongoing mysteries in Australian science. What wiped out the megafauna? Was it climate change before humans arrived? Or was it human predation or modification of the megafauna habitats? Rod's not convinced of any of these. He's working on a theory of his own, which emphasizes the significance of locality.
But what we're trying to see here is whether there's a regional pattern here of last appearance. So this is one of many sites scattered along the ranges here. And at each of the sites we're doing the sort of work you're seeing here, and gradually we put together a picture.
Looking at how...
This second skeleton could prove particularly useful because it's almost complete.
So to find bones in this good a condition and this complete a skeleton is a real special treat for us.
So you're excited?
I am. This particular specimen, what we would call that some of these bones are articulated, so they're still in the position that they would be in real life. For example, the radius and ulna that we have down the front here are still crossed like they would have been in real life, and the humerus that we removed, the upper arm bone, was articulated with them. So we know that that limb hasn't moved very far at all from where it fell when the animal died.
Removing and preserving the bones is painstakingly laborious work.
We're very fortunate, and we've got a group of volunteers that are putting in their time to spend the endless hours cleaning and soaking the bone.
Looks like a sweatshop, don't you think? I'm just saying.
This is a paleontology sweatshop.
Yeah, members of the community. And I sort of rather like the idea that, they're getting involved in the science.
So it's speed. Could you, look, when you're telling me off, could you at least pay attention? So you're wanting me to. So I better go like this. Is that right?
No.
Just say yes, just make me feel. You've got to build up my confidence.
And then I just dust it. It takes a long time, but I can see the bone. So how do I know I've got the dirt off and not the bone?
You don't think the
Well,
Just because it comes off easier?
yes, it comes off way easier. Bone is much more solid than dirt.
I feel like I'm talking to a professor.
Yes.
This is the pelvis. So across here is this region on the back of the animal here. So those areas that are poking out there, that's that, and that's at that end there.
That is a wide load.
Yeah, it is. Very much. Yes.
These excavated bones are giving us a clearer picture of what the Diprotodon looked like. But the crucial answer to when this creature died, ironically, isn't to be found in the bones at all. In fact, it's this fine Badlands sediment that holds more clues to solving the mystery. So the sediment actually is the key. You can't really use the bones.
You could try and date the carbon that was in the bones if you had collagen in there, the protein structure of the bone, but that's long gone. So the only thing you can really do is date the sediment in which they're buried. The sediment is more key to trying to understand the age of these animals throughout this region.
Because the Diprotodon skeleton was found whole, with its bones articulated, it's very likely it was buried soon after it died, making the sediment around it the same age as the fossils.
Rods enlisted the help of Dr. Eric Bestland, a specialist in ancient soils. So it's the bones that's the wow factor, but really it's the sediment that gives you the final clues to this puzzle, isn't it?
That's right. I mean, it's very exciting to find fossils, but if you don't know what context the fossils are in, if you don't know how old they are, if you don't know where they sit in the package of strata, the package of layers, then they're really scientifically not that useful.
So if you look at this area, I mean, this is an extraordinary area, what does this sediment tell you about the climate?
I mean, for example, you've got this dark brown band right in here.
Yeah, it stretches across the whole thing.
We think that was probably from a wetter period of time, and then the stuff below it was probably from a bit drier period of time.
Dr. Bestland estimates that these layers of sediment, from the top of the gully to the bottom, are between 10 to 20,000 years old. It was in a layer at the bottom of the gully that the Diprotodon skeletons were found. So I don't understand, if this is 20,000 years and the Diprotodons were found at the bottom there, I thought the Diprotodons were about 70,000 years old.
Right, yeah. So this is why we were very excited about this site, that it could be a very young Diprotodon fossil find.
So you thought you had the clincher that showed that the Diprotodons were around at the same time as humans and survived, in fact, many thousands of years.
We thought we had
that.
a major discovery. And
so what's going on?
Well, there's got to be something else in this gully system. There's got to be some other feature that we don't understand. Probably some erosional feature that we haven't recognized yet between this section of sediment and where the Diprotodon is.
But what is recognised is that the sediment found around the Diprotodon is definitely older than 20,000 years.
It's radiation expert Dr. Nigel Spooner who's provided that clarification. The method he's using is optical dating, which closely analyzes the quartz grains in the sediment.
Optically stimulated luminescence. So you need to take a sample of this dirt.
Yeah.
and you need to ensure that no light gets in contact with it.
Yeah, correct. The signal itself is very light sensitive, and what we're dating is the time the quartz grains last got exposed to sunlight, which is when the sediment was laid down burying the bones.
So how is this technique going to work?
We are looking at getting a minimum age here in practice. We certainly can rule out last glacial maxima. We're looking really at an age of around 45 to 50,000 years or upwards with optical dating.
That's the minimum age?
That's the minimum age it could be.
And that date puts it right back on the cusp of when humans arrived on the continent.
What other techniques might give us a more accurate date?
Thermoluminescence, and also some techniques you would probably not be aware of called post-infrared, infrared stimulated luminescence and thermally transferred OSL.
This sounds incredibly complicated.
They're pretty developmental, they're not simple, and we'll see how they work.
When are you going to be able to give us an age?
It'll be a few more months' work, it's not trivial.
While we'll have to wait for a definitive date on the bones, Rod's beginning to formulate his theory.
It seems like in these debates, everyone wants a simplistic answer. It's one thing or another, or a little combination, but you're saying that the ultimate explanation is going to be regional.
Well, you know, I've spent enough time studying modern animals to think that the picture is probably a darn sight more complicated than we would like. And, you know, my hunch is you probably had events that wiped out local populations and reduced the population overall to sizes where they became vulnerable to these other changes.
So you think here, these diprotodons may have been part of a last stand?
In this region. I think probably the last stand of the megafauna in this region is of the order of 70, 80,000 years ago.
So the youngest diprotodons to be found here would be 70 or 80,000?
Yeah, in other words, they would have vanished from here before humans.
Whether Rod's theory holds true all over Australia and provides the solution to the great extinction mystery will require the uncovering of a few more skeletons.